Alright, so the demo that I decided to talk about for this week is conservation of energy and has to do with work as well. And so with this demo, the best place to introduce it would be right after you talk about Hooke's law and springs and spring constants. And so for this demo, I made a bow out of PVC pipe. And now this bow is actually pretty easy to make. I'll post the link to the instructions on how to make it. But as you can see, I have a piece of PVC and another piece of PVC pipe that's actually inside of it, and one of these reflecting fiberglass rods that you can just buy at Home Depot. So then the construction of it is pretty simple, and I think that it illustrates Hooke's law pretty well. It's not a perfect model because it's not a perfect string. In fact, that's one of the questions that you can ask your students. What other factors are stopping this from being an ideal spring? And there's a few things that go into that. The first is that the limbs actually have some weight to them. So they have some mass and they have to travel, and so they're going to absorb some of that kinetic energy when it goes from potential energy to kinetic energy. Another really good question that you might pose to your students is, why can I shoot this arrow 50 yards when I can only throw an arrow 20 yards or 10 yards at most? So, and then you can go into talking about how the same force is being acted upon this, that you're applying a force to that bow, but but the impulse of it is going to be different. So you're getting a lot faster initial velocity than you would if you were to throw the arrow. Some other really cool things that you can do is have them calculate the range, or have them calculate the spring constant for this. Now, like I said, this isn't a perfect model for Hooke's law, but it is somewhat linear because a few things tend to balance out and cause it to be a linear relationship. So you can basically come up with a spring constant for this bow. Now, with this bow, a few things to keep in mind is that there are two limbs, and so you're going to have, when you calculate the spring constant of this bow, basically you're going to be calculating twice that, or so you're going to have to divide that in half in order to get the spring constant of the actual bow. Now, a few other things that would be cool to talk about would also be to talk about compound bows and about how they're used, because compound bows, they use a few different things. I've got one right here that's you can look at. So compound bows, they use pulleys right here, and then also down here. I don't have it set up completely, but these pulleys, they in effect allow you to cut the weight of the force that you actually have to apply in order to pull it back. And then also, they also give you a lever arm. So I don't know if you can see inside of here, but the string itself is actually attached on the top of the pulley, so you're creating somewhat of a torque, and that's why you're able to get the let off when you pull it back far enough. So some pretty cool things that you could talk about there, and about useful nonlinear models as well. So hopefully you guys like this video. I enjoy archery quite a bit, so I kind of like making bows, and when I found the PVC pipe bow, I was pretty impressed by it. This bow pulls about 40 pounds, so it's definitely well worth it to make. It's pretty simple, but it definitely demonstrates the topic quite well.